So today's objective is I will be able to prove that a quadrilateral is a parallelogram. So just so you know, this section is a lot of proofs. I went ahead and included it for you so that you would spend more time thinking about what I'm saying in this video as opposed to writing at the same time. So AB is congruent to CD. So AB is congruent to CD. And then BC is congruent to DA. And so that is shown here with the markings. All right. So when you're trying to prove that the quadrilateral is a parallelogram, we also need to look at the diagonals. So we will draw in diagonal BD. Okay, and that's a construction, and then we have the given information. So we also know that BD is congruent to BD, and that is the reflexive property. Okay, when it's congruent to itself, it's the reflexive property. So we can actually conclude that this triangle and this triangle are congruent by side, side, side. Look, I have a side, this side, and then this side. Three sides that are named that are corresponding and congruent. So we can conclude then that angle ADB, this one, ADB, and CBD, this angle, are congruent. And we can conclude that CDB, this angle, and this angle are congruent. Okay, by corresponding parts of congruent triangles are congruent. So by CP, CTC. So remember, let me backtrack. Once you confirm, once you can conclude and prove that two triangles are congruent, right away, any other corresponding parts of the triangle that are named are also congruent. And so that's why we say by CP, CTC. Okay? Now, AB is parallel to DC and BC is parallel to AD. So the opposite sides we can now say are congruent. Why? Because of the converse of the alternate interior angles theorem. So in other words, because in the step above we concluded that the blue angles were congruent and the orange angles are congruent, if you notice that they are alternating sides of a transversal and are congruent. And since those alternate interior angles are congruent, you can conclude that the opposite sides are parallel. So ABCD is a parallelogram based on the definition of a parallelogram. Okay? Let us look at this next example. It says, given that angle S is congruent to angle U, so those are marked by the markings. I'll color code it for you. So S and U, and then V and T are congruent. Prove that it is a parallelogram. So this information is given. Now, VT is a shared common side. So they have this side in common. Okay, that's the reflexive property of congruence. So by angle, side, okay, the two triangles are congruent. Now, because the two triangles are congruent, all the other corresponding parts that we mentioned are also congruent by CP-CTC. So we can say that ST is congruent to VU. So opposite sides of a parallelogram are congruent. And SV is congruent to TU. Okay, and that's by the corresponding parts. So we conclude that it is a parallelogram because both pairs of opposite sides of a quadrilateral are congruent. Then the quadrilateral is a parallelogram. Okay? Again, you guys need to be using the reference materials for this chapter to understand the properties of a parallelogram and then how to justify finding the information in a quadrilateral to prove that it is a parallelogram. All right, angle A is congruent to angle C. And angle B is congruent to angle D. All right, so prove that ABCD is a parallelogram. Well, angle A is congruent to C, B congruent to D. This information is given. Well, inside a quadrilateral, so the sum of the measures of the angles of a quadrilateral is 360. Remember we talked about the sum formula. Sum is equal to n number of sides minus 2 times 180. And so since this is a quadrilateral, that means there are 4 sides. The sum of the interior angles is equal to 360. So since A is congruent to C, that means that this is also y degrees. And since B is congruent to D, D is x degrees. So if we add up all 4 angles, the sum should be 360. Okay? So here we have 2 groups of x plus y, right? We have x plus y plus x plus y. So we rewrite it this way. Now let us do the distributive property, or you can divide both sides by 2 here. Okay, so we divide it by 2, and that's how you get 180. So that's the division property of equality. Now, angle A and angle B are supplementary, and angle A and angle D are supplementary. So let's go back and take a look. We said C and A were y degrees, B and D are x degrees. So if x plus y is equal to 180, that means they are supplementary. So any pair of x and y means that they are supplementary. So here, this sum is 180, this sum is 180, this sum is 180, and this sum is 180. So here we say angle A and B are supplementary. A and B are supplementary. And then we say A and D are supplementary. So consecutive angles either way are supplementary. And so we can conclude that AD is parallel to BC and AB is parallel to DC. And that's by the converse of the same side interior angles postulate. So because these 2 consecutive angles are supplementary, they are same side interior angles. And since they are same side interior angles, then this would act like a transversal, and these would be the parallel lines. This would be the parallel line to here. Okay? And then similarly, if we say that these 2 are supplementary, okay, this would be the transversal, and then these 2 would be parallel. Okay? So, since the opposite sides are parallel and the consecutive angles are supplementary, ABCD is a parallelogram. All right, given that angle J is congruent to angle NKL, so let me mark these up. So angle J is congruent to NKL, so NKL, that would be right here. And then MLK is congruent to NKL. And then angle M is congruent to KLP. And JKL is congruent to KLP. Okay, so this information is given, right? Angle J is congruent to NKL, MLK is congruent to NKL. Well, it is also given, or angle J is congruent to MLK. Why? Because look here. Let me write it out again. So we have angle J is congruent to angle NKL, and then we have angle MLK is congruent to angle NKL. So since this one is congruent to NKL and this one is congruent to NKL, by the transitive property we can conclude that angle J is congruent to angle MLK. Okay? So J is orange with the other orange one, or yellow rather, so yellow. And then MLK is the blue angle. So if you notice here, we have the yellow and yellow, and then we're saying the blue and the blue. See how the blue and the yellow are on the same? So that is correct. Angle J should be equal to MLK. All right? So angle M is congruent to KLP, so it's the same idea here. Angle M is congruent to KLP, and then JKL is equal to KLP. So since both of these are equal to KLP, we can say they are equal to each other. And that, again, that is by the transitive property of congruence. So in other words, this reddish color here, the M with the other red, and then JKL, and see how the red and the purple are together? So then this other purple one here is also congruent. So the red and the purple angles are congruent. So we conclude that JKLM is a parallelogram. So in other words, what we were saying was that angle J, and we showed that MLK, this angle, are congruent. And then we showed that angle M was congruent to this one. And so since opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay? All right, next, prove that AC and BD bisect each other at E. So, I'm sorry, it is given that AC and BD bisect each other at E. ABCD is a parallelogram is what we're trying to prove. So AC and BD bisect each other at E. That means that this piece is congruent to this piece, and this piece is congruent to this piece. Okay? Let us take a look here. Angle AEB, which is right here, and CED, which is right here, are vertical angles. Okay? And so, by side angle side, these two triangles are congruent. Okay? So because those two triangles are congruent, all the other corresponding parts of these triangles are congruent. So angle BAE, this angle here, and DCE are congruent by corresponding parts. And so we can conclude that AB is parallel to CD. So AB is parallel to CD, because if this acts like the transversal, those purple angles are alternating and are interior congruent angles. So we prove that AB is parallel to CD. Now let's take a look at the next piece. So we say that AE is congruent to CE, which is what we marked. AE is congruent to CE. And then BE is congruent to DE. This one here is congruent to DE. That's the definition of a segment bisector, since here in the given information we said they bisected each other. Okay? And so triangle BEC. So now we're going to analyze here. BEC and triangle DEA. So actually, before we move forward, let's look really quickly here. It says BEC and angle DEA. So BEC, this angle, and this angle here are vertical congruent angles. So again, by side, angle, side, the two purple triangles are congruent. Okay. So by corresponding parts of congruent triangles, ECB, so this angle here, and then EAD, this angle here, are congruent, well then you can see that this side here and this side here are parallel because this here is the transversal, and those blue angles are alternating and are interior congruent angles. So it was the same thing here. So since the opposite sides are parallel, then that is the definition of a parallelogram. All right, let's take a look at this proof. So TQ is congruent to RS. So TQ is equal to RS. That's this marking. Okay, and then these angles are congruent to each other. QRST, prove that QRST is a parallelogram. So we have the given information. Okay. Angle QXT, this angle, and SXR, right here, are vertical angles, and vertical angles are congruent. Okay, so we can conclude that this triangle and this triangle are congruent by angle, angle, side. Actually, I mislabeled that. It should go in order, so it should be angle, angle, side. Okay? So by angle, angle, side, those two purple triangles are congruent. So after you've proven that those two triangles are congruent, we can conclude that the other corresponding parts of the triangle are also congruent. So QX, so we can now conclude that QX is congruent to SX, and TX is congruent to XR. Okay? And so we can say that QS and TR bisect each other. So QS, let me use a different color. QS and TR bisect each other. Why? Because I see 2 here and 2 here. I see 3 here and 3 here. That means that this section is congruent to this piece, and then the other part of that diagonal is congruent to the other part. So since they bisect each other, that's the definition of a bisector. So since the diagonals bisect each other, then the quadrilateral is a parallelogram. Okay, problem 4. So for what value of y must PQRS be a parallelogram? Well, if you recall, in a parallelogram, opposite sides are congruent. So x plus 2 is equal to y, and 2x minus 5 is equal to 2x plus 1. Okay, so let us go ahead and solve. Sorry, this should be 3x. Okay, I'm going to solve for x here, so subtract 2x, subtract 2x. This is x minus 5 is equal to 1, add 5 on both sides, and so x is equal to 6. So let's go back and substitute in. So 6 plus 2 is equal to y. This is 8, and that is the value of y. For what values of w and z must ABCD be parallelogram? So remember that opposite angles are congruent. So we can say 3w plus 10 is congruent to 5w minus 30. So 5w minus 30 is equal to 3w plus 10. And then 7z plus 5 is equal to 8z minus 10. So let me solve this one first. We subtract 3w and combine our variables on one side. And then we move our constant using a zero pair. And then we divide both sides by the coefficient to get the variable by itself. And so w is equal to 20. And for z, we have 7z plus 5 is equal to 8z minus 10. Again, let us get the variable to one side. Then move the constant over. And so 15 is equal to z. Again here, opposite angles are congruent. So 4x plus 13 is equal to y plus 10. And then 3y minus 2 is equal to 12x plus 7. Now, you can use systems of equations to solve for this one. You can also recall that consecutive angles in a parallelogram are supplementary because they are same side interior angles. So this sum here is 180 and this sum here is also 180. So since these variables require doing systems of equations, I prefer to just use same side interior. So I'm going to say 4x plus 13 plus 12x plus 7 is equal to 180. And then y plus 10 plus 3y minus 2 is equal to 180. And so let us combine our like terms. Subtract 20 on both sides. 16x is equal to 160. Divide both sides by 16. X is equal to 10. Y and 3y is 4y. 10 and negative 2 is positive 8. Subtract 8 on both sides. 4y is equal to 172. Divide both sides by 4. Y is equal to 43. Okay, so let's look at a few more proofs. Okay, we're almost done with this section. Hang in there. So, can you prove that the quadrilateral is a parallelogram based on the given information? If so, write a paragraph proof, and if not, explain. So, AB is 5, and DC is 5. So, these opposite sides are congruent. The measure of angle A is 50, and the measure of angle D is 130. So, if it is a parallelogram, recall that consecutive angles have a sum of 180. So, 50 plus 130 is equal to 180. Okay, so because it is given that the measure of angle A is 50 and D is 130, by same side interior angles, A and D are supplementary. So since these are supplementary, we can conclude that these lines here are parallel. Okay, so it is given that AB is 5 and CD is 5, so the opposite sides are also congruent. So therefore, ABCD is a parallelogram by this theorem. Again, go back and look at your reference materials to recall exactly what that theorem states. And so you can prove that this is a parallelogram. Okay, so we discovered that the angles are consecutive and our same side interior, they are supplementary. The opposite sides were congruent for AB and DC, and AB and DC are parallel. All right, given that HI is congruent to HK, so HI is congruent to HK, and JI is congruent to JK, prove that it is a parallelogram. you are given that two pairs of consecutive sides, so two sides next to each other, are congruent. So by theorem 6-8, you need to show that both pairs of opposite sides are congruent, not consecutive sides. So in a parallelogram, like here it's showing this side and this side. The two sides are next to each other. They are consecutive. But in order to define a parallelogram, the opposite sides, like this one would have to be congruent to this one, and this one would have to be congruent to this one. And in this situation, that's not the case. So you cannot prove that this quadrilateral is a parallelogram. All right, so given that the measure of angle N is equal to Q, so N is equal to Q, and P is 141, can you prove that this is a parallelogram? Well, remember that consecutive angles are supplementary. So let us see, is 141 plus 39 equal to 180? Well, 9 plus 1 is 10, carry your 1, that's 8. So yes, these are 180, and these are 180. Their sum is 180. So it says since the sum of the angle measures of a quadrilateral is 360, okay, so the proof took a different approach. Remember we said earlier that the sum of the angles inside a quadrilateral are 360. Well, then we would have to add up all these angles and find the missing angle M to see if it is congruent to its opposite angle, P. So we have 39 plus, actually we have two groups of 39, so 2 times 39 plus 141 plus the measure of angle M is equal to 360. And so 2 times 39 plus 141 is 219. So 219 plus the measure of angle M is equal to 360. So we subtract 219 from both sides. The measure of angle M is equal to, so 360 minus 219 is equal to 141. Okay? And so, since angle N is congruent to Q and P is congruent to M, N is congruent, so the measures are equal to each other, then the angles are congruent to each other. That's what the statement says. So therefore, it is a parallelogram by theorem 6-10. In other words, because the opposite angles are congruent, M is congruent to P and Q is congruent to N, then this quadrilateral is a parallelogram. All right, so GE is 24 and GH is 12. DF is 32. DF is 32. And HF is 16. Okay? Well, taking a look here, let's see. It says here GE is 24, so GE is equal to 24, and GH is 12. Okay? So GE is equal to GH plus HE. Okay? That's by the segment addition postulate. So if I add this piece here with this piece, the total should be 24. So GH is 12 plus HE. So when we solve for HE, we find that HE is 12. Okay? And similarly, so we said here DF is 32 and HF is 16. So DF is made up of the two segments DH plus HF. Well, if DF is 32, DH is the unknown, and HF is 16, well, we can solve for DH by subtracting both sides by 16, and DH is 16. So I see here that this one is congruent to this one, And this one is congruent to this one. So we see here that by theorem 6-11, the diagonals bisect each other. Therefore, you can prove that the quadrilateral is a parallelogram. Okay? Given that the measure of angle E is equal to G, so E is equal to G, F is 107, prove that it is a parallelogram. Remember that a quadrilateral measures 360. So we have two groups of 72 plus 107 plus the measure of angle D. And let us solve. So 2 times 72 plus 107 is equal to 251. Subtract both sides by 251. .109 is equal to the measure of angle D. Okay, so since the opposite angles are not congruent, like D and F are not congruent, then this is not a parallelogram. There's not enough information to conclude that it is a parallelogram. You also could have looked at the consecutive angles and seen here that this was 107 plus 72 is equal to 179, not 180. And so since they are not supplementary, this quadrilateral is not a parallelogram. All right, last example. So a truck sits on the platform of a vehicle lift. Okay, so the red part here is the vehicle lift. Two moving arms raise the platform until mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? Well, if you notice that the angles of PQRS change as platform QR rises. So QR is the platform, the red line. So, but its side lengths remain the same. So the side length between here and here and the platform will not change, and then the arm length will never change. Okay, so even though it's lifting, it may be higher, it may be lower, so the angles might change, but the opposite sides, both pairs of opposite sides are congruent. So PQRS is a parallelogram by theorem 6-8, which again states that opposite sides are congruent. By the definition of a parallelogram, then, so since we can conclude it is a parallelogram, then the opposite sides are parallel. So PQ would be parallel to RS. And since the base of a lift PS lies along the ground, the platform QR, and therefore the truck will always be parallel to the ground. Okay?